So today we're going to be talking about linear regression, and we're still talking about line of best fit, and we're going to be doing that in the calculator. So our equation or our essential question today is, how can you use a graphing calculator to find the line of best fit? So we've got a few vocabulary words to go through today that are going to be relevant to the lesson. Our first one is linear regression. Linear regression is an algorithm used to find the precise line of best fit. So like I said before, we're going to be doing that in the graphing calculator today. We're also going to be talking about correlation, how well our data correlates. So that's the relationship between the variables. Are they all kind of really close together or really far spread out? Causation is when we have a change in one variable, it produces a change in another. So if my x value changes, it would cause my y value to change. And our last vocabulary word is going to be correlation coefficient. So this correlation coefficient is going to be found when we graph it using the graphing calculator, and it's going to show how well the data are modeled by the equation. So if our data is really far spread out, it might not be very accurate, but if our data is really close together, it might be more accurate. Go ahead and pause that if you need to finish copying down the vocabulary. So along with the correlation coefficient, if our correlation coefficient is between or has an absolute value that is greater than or equal to 0.8, then we would call that a strong correlation. So our data would be pretty close together. If our correlation coefficient, or R value, is between, that's what this means, is between 0.8 and 0.5, that would mean that it's a moderate or kind of in the middle. And then if our R value has an absolute value that is less than 0.5, we would call that a weak correlation. So if we look over on the right, we see we have a chart. If we have a weak correlation, it's going to be kind of scattered all over the place, and our correlation coefficient for that was less than 0.5. And then if we take a look in the middle, we've got a moderate correlation, and that they kind of go in a positive direction. They're kind of close together. So that's a little bit less than 0.8. So that would be a moderate correlation. And then in our next example, we have a strong correlation. They all kind of make a straight line and they're really close together. So that absolute value of the correlation coefficient is 0.97. So that's a really strong correlation. So that's how we describe what we see when we look at a scatter plot. So now we're going to get into how to find that line of best fit from the Desmos calculator. So the first thing that we're going to do in Desmos is build a table when we enter the data. So we're going to build the table, and we're just literally going to type in what they give us for our x and y values. After we build a table, we're going to enter the regression formula. And our regression formula for Desmos specifically is going to be y1, and then we're going to have a little tilde mark, m x1 plus b into the calculator. After we do that, we're going to get our correlation coefficient. It's also going to graph a line for us. That is our line of best fit. It's going to tell us what our slope is, and it's going to tell us what our y-intercept is so that we can write the equation for our line. So it's going to give us all the information that we need by just plugging in that correlation or that regression formula. So that's what we would type into Desmos. So we're going to go ahead and look at an example. So our example down below is given. The table shows Jackie Robinson's total hits during each season of his major league career using a graphing calculator to write an equation for the best fit line, then find and interpret the correlation coefficient. So this is the data set that we're going to be using, and I've gone ahead and plugged it into Desmos. So all I did was take that chart and I put my X values on the left and my Y values on the right. So now that I have that in Desmos, we can take a look and zoom out a little bit to find, since we have some really large values here. So our scatter plot was plotted for us. And then underneath that chart, I'm going to type in our formula. So we've got Y1 and then our tilde mark and then mx1 plus b. And underneath that, you guys will see all of the information. We've got our correlation coefficient telling us that it's a strong negative correlation. We've got our slope and we've got our y-intercept. So we're going to come over and we're going to plug that into our notes. Our R value, our correlation coefficient was negative 0.8, and I'm just going to round. And since the absolute value of that is positive 0.8, that would mean that we have a strong correlation. Our slope is negative 10.3152, and our y-intercept is 20,278.8. So we're going to use that information to write our equation. So remember, x plus b for our linear relationships. So I'm going to take the slope that they gave me and fill in for m. And then I'm going to replace the b, my y-intercept, with the y-intercept that they gave me in the calculator. And like we said, since our correlation coefficient was negative 0.8, that would mean it has a strong and a negative correlation. So the last thing that we're going to go over is how do we use that formula. So now that we have that correlation and the regression graph, they gave us this line of best fit. And so now we're going to use that to predict. We're going to extrapolate our data. So when we extrapolate, that means we're predicting what we're going to be doing. So that means predict. And when we do that, we're just plugging in a value for X. So they asked us what the total hits would be in 1960. Our years are our X values, so I'm just going to replace that for X. So instead of Y equals negative 10.3152X, we're going to replace the X with 1960. And then we're going to go ahead and calculate that to predict what his total hits would be in 1960. So when we multiply that out and add our y-intercept, we get 61.008. So we can say that his total hits should be about, as we're rounded, 61 hits in 1960 based on the data. This is an approximation. This is kind of a guess. We used that line of best fit. We plugged in the number they wanted us to find specifically and calculated it. So make sure you have all of that copied down.